Assalamualaikum warahmatullahi wabarakatuh to Dr. Muhammad Noor. We are from group number 3. My group members is Nurul Arisha, Nur Shahira, Nurul Nabila, and me, Normazatu Akila binti Cik Ismail, GE 180118. We are going to present our project about voltage set caused by short circuit, mitigate using DVR technique. What is the voltage sag? It is a short reduction of RMS voltage when RMS voltage decreases from 10 to 90% of nominal voltage in less than 1 minute. Voltage sag is a major power quality problems that concern utilities and residential area. Because of modern environment, there are quite a lot of high technology that were produced that mostly sensitive with the power quality. Poor power quality can lead to the disoperation or electrical equipment damage. Thus, there are an equipment that can detect voltage sag using by injecting voltage into the system to improve the performance of power quality, which is dynamic voltage restorer. How about the causes of the voltage sag? There are several causes of voltage sag, which is due to line to ground fault or short circuit in the system. Other than that, when to start up the large load, lights, induction motor for the industrial, and refrigerator or air conditioner for the residential area. More than that, it is caused by natural disaster like lightning, floods, or an accident. Although the utilities have made some investment to improve the power quality performance, however, it cannot avoid the external factors like this. This problem will lead to the shutdown or disoperation of electronic devices that will costly because the electronic devices may be damaged. The objective of this project is to investigate suitable mitigation technique to improve the performance of the power quality, to simulate and analyze the technique using the MATLAB software, to observe the effectiveness of the technique when applied to the system in terms of magnitude and phase shift.
My name is Nur Nabila. I will continue methodology part. Okay. The method used of this project is dynamic voltage restoration (DVR). DVR is one of the methods to overcome voltage tax problem. Okay, the list of components that we use is generator, transformer, voltage set, bus bar 11 kV, which is primary part of transformer, 0.451 kV, which is secondary part of transformer, and the bus bar is with load. Then 3-phase circuit breaker, TBR, and last is RLO. For the block diagram, generator go to the bus bar or 3-phase IV measurement between bus bar and transformer. The voltage is go to voltage side, then the problem will occur. After that, from transformer go to bus bar back, and between bus bar and 3-phase circuit breaker, the voltage go to DVR, and between circuit breaker to the net bus bar, same, go to DVR, and then the bus bar we go to RN load, which is consumer load. Okay, the flowchart is we start the program. We use MATLAB, and then we develop system of DVR with voltage set. After that, insert the value and parameter for each component, and then run the simulation. After we run the simulation, we observe the effect of the voltage set and DVR in plotted waveform. What we get, is it suitable with theory or not? And then simulation is success or no. If no, we change the parameter and return back to insert parameter value. If yes, then we get the suitable waveform and the simulation.
Okay, my name is Nura Arisha binti Muhammad Zamri, matrix number DE180106. I will present about the simulation part. Okay. The standard voltage is used in Malaysia, supplied by the Tenaga Nasional Berhad TNB. The source, which is generator, is 11 kV, is fed from the TNB distribution substation, which is PBU. And then 11 kV is connected to the step down transformer to convert 11 kV to 415 V before delivered it to the consumer load. Okay, for the load we use RL load, which is non-sensitive equipment and can tolerate with the sagging condition. Before I forgot, this is the model without DVR or vortex. After we run, this is the result, voltage and current without any fault. This is the model of the system using the voltage and DVR controller. Voltage occur at the step down controller caused by short circuit. So DVR will detect and restore the set voltage before delivered into the consumer load. So the consumer will get the stable power. Okay, for the voltage set and DVR controller, I will pass to my friend Nur Shahira will explain about it. Okay, for the simulation, fault will generate at the step down transformer and to produce set phenomena which are single line to ground fault, double line to ground fault, and balance three phase fault. Okay, first, this is the result for the single line to ground fault. Okay, this is phase A, phase B, and phase C. We choose phase A to have set condition. Okay, this is the result for the single line to ground fault. Uh, so we choose phase A to have set condition, and then the others will be a stable condition. And for the V injection, which is voltage set at the phase A, we restore at the injection transformer in the DVR controller. So our load will produce stable waveform and without any fault to without any fault or disturbance, the customer will use their appliance without any error or any fault. Next, for the double line to ground phase port, we choose phase A and phase B to have set condition, and then we run the simulation and we get the result. Okay, this is the result for the double line to ground fault. So step down transformer will be like this. Between 0.2 to 0.3, we have the set condition in the after step down transformer. So will be injection, which is DVR, we restore the voltage set and then deliver the stable condition to the load. So the last phenomena, which is balance three phase fault. So all the phase in set condition, we run it. So all the phase will in the set condition between 0.2 until 0.3. So the it's same with the others. So the injection transformer. So the DVR we restore or reduce the voltage set, and then the load or the consumer load will have the stable condition. So consumer can use their electrical power without any disturbance. Okay, that's all from me. Thank you.
Okay, my name is Nur Shahira binti Muhammad Samri, matric number DE1A0124. Okay, for my part, I will explain about the subsystem of the DVR that we use to mitigate the voltage set. Okay, in this DVR, we have built out the circuit. Okay, the voltage set, we enter here and it will go to the controller. Okay, this controller are able to detect the voltage set that occurrences in the system, which it will calculate the compensating voltage, generate trigger pulses of the PWM inverter, and also stop triggering pulses when the occurrence has stopped, has passed. Okay, in this controller, it is controlled using the PI controller. Okay, the below is then transformed in the DQ term. Here, and then the voltage set is detected by measuring the error between the DQ voltage and the reference value. The D reference is set to this the D reference is set to the rated voltage, and then for the Q reference is set to 0. Okay, the DQ component, which is here, DQ component of the load voltage are compared. We compare with the different value, and G error signal is then entering the PI controller. It's the PI controller. Okay, this PI controller block are used for error signal D and also error signal Q. Okay, for the signal Q, we have set it to the 40, and then for the integral gain, we have set to 155. While for the Q, error signal Q, the proportional gain we set to 25, and then for the integral gain we set to 260. Okay, and then the PI controller is okay. This here is the PI controller that we have built. Okay, this PI controller is a feedback controller which drive the plant to the controller which awaits some of the error difference between the output and the desired set point, and the integral of the value. Okay, all the gain that are selected is used to tune out the error signal in the D and Q, so the signal is stable and will respond to the system. Okay, and then the voltage from this controller we enter this PWM inverter. Okay, this PWM inverter is used to convert the DC source to the AC voltage. Okay, this is the IGBT inverter. Okay, the AC voltage we then go to this filter which is RL and RC as filter. It will reduce any sag in the voltage. And then the voltage without any sag or harmonic is then injected back to the line by the injection transformer. Okay, this is where the voltage without any sag we send back to the line, and then it will send to the customer load. Okay, next I will explain the result of our total harmonic distortion of the phase A. Okay, the first one is for the input voltage. Okay, the total harmonic distortion that we get for the input voltage is 68.54%. Okay, the next one is for the injection of voltage. Okay, the total harmonic distortion of phase A for the injection voltage is 55.91%, which is more smaller than the input voltage. Okay, the last one is for the load voltage. Okay, the THD of the load voltage that we get is 2.28%, which is more smaller than the input voltage and also the injection voltage. Okay, from this result, it can be concluded that this system become more stable with less harmonic occur. Okay, this is because the lower the THD, we produce a higher efficiency of the system.
As the conclusion, okay, this project is to overcome the voltage side when the problem is occur by using DVR. This method operates by using regulating the currents. The part in DVR are composed a reverse rectifier assembled with inverter and injection of transformer. The results show voltage drop for 1 second due to fault. When DVR is is attached to overcome the problem. The voltage at the time fault occur be normal. Okay, that's all from me. Thank you.